2, we're going to look at analyzing conditional statements, and this is kind of where we're going to start getting into this idea of conditional statements, and it's going to lead to a lot of future discussions regarding theorems and things of that nature. Okay, so first of all, what is a conditional statement? It's very simply a logical statement that has two parts. We have a hypothesis and a conclusion, and usually we'll write it as an if-then statement. It's a lot easier to understand when we write it as an if-then statement. And the if part note is called the hypothesis, okay, of the statement, and the then part is the conclusion. Okay, so hypothesis, conclusion, and that's what we're going to kind of go with. So we're going to rewrite these conditional statements in if-then form. So an angle whose measure is 90 is a right angle. Should be angle, not angles. Okay, so if an angle is 90, okay, the measure of an angle, I should say, is 90. I'm being a little bit not sloppy, but I'm just going to use symbols so that I'm not having to write out so many words. So if an angle measures 90 degrees, then it is right. Okay, that's what that's saying. The second one says all squares have four sides. Okay, in other words, if a polygon is a square, then it has four sides. Okay, and we're going to look in a little bit here at how to determine whether or not these statements are true or false. So we'll visit that in the future. Right now, we'll just focus on if-then statements. When x equals 3, x squared equals 9. So if x equals 3, then x squared is equal to 9. Okay, those are conditional statements. So if this, then that follows. Okay, and again, these if-thens could be true, could be false. When we talk about theorems, obviously they're always going to be true. Okay, now we're going to talk about this idea of negating something. The negation of a statement is the opposite of the original. Okay, so if I want to negate this statement here, it says the ball is red. The negation would be the ball is not red. We're not going to say the ball is blue or the ball is green or the ball is orange. The ball is not red. To negate this, it says the cat is not black. The opposite of saying that is to say that the cat is black. Okay? Some people think of negating as always having not in it. Negation always depends on what your initial statement is. The negation of that initial statement is always just the opposite of that. Okay? In addition to conditional statements, anytime we have an if-then statement, we can look at three different things regarding that if-then statement. Okay, we can look at the converse, we can look at the inverse, and then down here at the bottom here, we can look at the contrapositive, which we'll get to momentarily. Okay, so the converse of a conditional statement is formed by switching the hypothesis and conclusion. Take your two parts and flip-flop them. For example, okay, again, we're going with this statement up here. Okay, let's see if my marker will work. Not sure why it's not working, but anyway, we're working with this statement. It says if an angle measure is 90, then it's a right angle. So the converse of that would be if an angle is right, then the measure of that angle is 90. Okay, we just took the two pieces and we flip-flopped them. That's what it means to look at the converse. The inverse of a conditional statement is formed by negating both parts. Okay, so reset. I'm going back up here to the top, looking at that again. So now I look at the first part. If an angle measures 90, the opposite of that, if the measure of an angle is not 90, is the negation of that. Then I negate the second part. It is not right. Okay, it's not a right angle. So again, inverse, negate both parts. Converse, flip-flop both parts. And then the contrapositive combines both of the ideas, okay? So to find the contrapositive, you flip-flop and negate. Okay, flip-flop and negate. So in other words, you'd say if an angle is not right, then the measure of the angle is not 90 degrees. Okay, so inverse, converse, contrapositive, and we're going to talk more about these here momentarily. All right, so here we go. We're going to write this thing in if-then form, and then we're going to look at whether or not each statement is true or false. Okay, so I'm going to be a little bit, I don't want to say sloppy, but I'm just for time's sake in the video, I don't want to spend a lot of time writing things. Okay, so the if-then form would be if you're an Olympian, I'm just going to use O. If you're an Olympian, then you're an athlete. Okay? Okay, if you're an Olympian, then you're an athlete. So it says decide whether each statement is true and false. Let's write them all first, and then we'll talk about them. Okay, so the converse means flip-flop. If you're an athlete, then you're an Olympian. Okay? Inverse, negate both parts. Again, I go back to my original, negate it. Okay? If you are not an Olympian, then you're not an athlete. Again, I'm running out of room here. I apologize if you're having a hard time reading my writing. I don't have the best penmanship, as I'm sure you've noticed already. And then finally, the contrapositive means flip-flop and negate. Okay, so if you're not an athlete, then you're not an Olympian. Okay? So the second part says go back to determine whether they're true or false. If you're an Olympian, then you're an athlete. I think that would be true, right? If you're an Olympic, if you compete in the Olympics, I would consider you an athlete. All right? If you're an athlete, then you're an Olympian. False, right? Well, how do you know that's false? Well, do you consider a professional football player to be an athlete? I would say yes, and clearly professional football players are not Olympians, okay? If you're not an Olympian, then you're not an athlete. Well, same argument, okay? So suppose this is true, okay? So you're not an Olympian, okay? You're an NBA basketball player, okay? You're an NBA basketball player. That's not an Olympian. Then you're not an athlete. Does that follow? Clearly not. That's just not logical. It doesn't make sense, okay? And then the contrapositive, if you're not an athlete, okay? So you don't play sports, okay? Then you are not an Olympian. That's going to be true. The only way to be an Olympian is to be an athlete. That's what the Olympics is. It's an athletic competition, okay? So when you're talking about true or false, you assume the if part is true and then ask yourself, does the then part have to be true? If the answer is yes, then it's true. If the answer is no, then it's a false conditional. Okay, we're going to look at this in terms of perpendicular lines. It says if two lines intersect to form a right angle, then they are perpendicular lines. Okay, the converse would be if two lines are perpendicular, then they form a right angle. Okay, a right angle. That's not. It looks like art. It should be a right angle. Okay, is that true? If two lines are perpendicular, what does that mean? That means that they form a right angle. This is a true statement. Okay, and that's how we make note of perpendicular. We use that little upside down T. Okay, so it says determine whether or not each statement is true or false. Okay, so as we go through this, it says AC is perpendicular to BD. That's true. Okay, look at this. Look at the diagram. It's a right angle. AED and BEC are linear pair. AED, BEC, that's clearly false. They're not linear pairs. They're vertical angles. Okay, now we're looking at a different diagram. It says JMF and FMG. JMF and FMG are supplementary. Well, they form a linear pair, so they do have to be supplementary. So that's a true statement. Okay, M is the midpoint of segment FH. There's nothing to tell us that. They don't tell us how long they are. They don't mark it, so we have to say that's false. Can we say they're perpendicular? I'm going to have to say no. They don't tell us if it's a right angle or not. And then it says JMF and HMG are vertical angles. That is a true statement. All right. So again, just looking at diagram, determining whether or not statements are true or false. And then the last idea we're going to look at is this idea of biconditional statements. When a conditional statement and its converse are both true, then you can write them as a single statement that contains the phrase if and only if, and we usually use IFF just to make save some time. Okay? So for example, a definition is two lines are perpendicular if and only if they intersect to form a right angle. It means you can read that both ways, okay? If two lines are perpendicular, then they intersect to form a right angle. And you could say if two lines intersect to form a right angle, then they are perpendicular. It goes back and forth, okay? Note here that any valid definition can be written as a biconditional. All right? So we write the definitions as a biconditional. We drop the if and the then, and we put if and only if in the middle. Okay? So it says if two lines lie in the same plane and do not intersect, then they are parallel. That is a true statement. Okay? So what we'll say is two lines are parallel. That's how we mark parallel. If and only if they lie in the same plane and do not intersect. Okay? And then the second part of that, okay, the second one again, an angle whose measure is 90 is a right angle. Okay, it should not be angles. So an angle, and you might have to change some of the words around here. An angle is right if and only if its measure is 90. Okay, and so again, this section is all about getting you familiar with conditionals, biconditionals, so that as we look at theorems and definitions throughout this semester and throughout the school year, that you're able to understand what they're saying, because most of them are going to be in if-then form. Okay, so as always, any questions, have them ready to go in class.